Hello, my fellow techies. Today we're going to be going over how to identify all possible combinations of items in a list using Python. Let's get to it. So on paper, this problem seems pretty simple, right? We're just identifying all combinations of numbers. So just the number 1, the number 2, the numbers 1 and 2, 1 and 3, 1, 2 and 3, so on and so forth. You would imagine that a kindergartner would be able to do this, right? But what if we had a million numbers? That obviously is more of a job for a computer than for a human, particularly not for a kindergartner. So how do we convert this into code then? That logic that we just described, identifying every single combination. Well, the easiest way to do this, the most elegant way, is by using a recursive algorithm. And if you're not familiar with recursion, recursion is when we call the function in the definition of the function. So in order to stop calling itself, we need to have what we call a base case, a way for this function to know when to stop calling itself. So in this case, and what I'll do is I'll just walk you through the steps that I'm doing. I'll tell you what I'm doing, and then we'll go through the why after, and we'll do a pretty thorough analysis. So our base case, we're going to say if the length of our iterable is equal to 0, and our iterable is just our list of numbers. So if we don't have any numbers on our list, then return a list with another empty list inside of it. Now, why would we not have any numbers in our list, right? Because we're obviously going to be passing numbers into this. Well, that's the base case. So if we're going to be cutting numbers out of this list, how are we going to do that? Well, first, before we get there, we're going to keep track of all of the combinations of numbers that we identify. And this is ultimately going to be what we return. So we're going to put all of our combinations into this list. And then we're going to get to this where we start cutting numbers out. So we say for combo in combinations, this is our recursive call, with the iterable starting at the first index instead of at the 0th index. So in this way, we cut one number out every time we have a recursive call. And then when we have no numbers left, then we have our base case and we return this guy right here. And you'll see why. Again, we're going to go through the analysis. So for right now, though, we're going to finish the algorithm. We're going to say for combo in combinations of the iterable starting at the first index. And then we want to identify our combos. So specifically, we're going to identify the combo that we're iterating through. And then we also want to do the combo plus the iterable at index 0. And that's actually the whole algorithm. At this point, we can say return combos, and we print this out, and we see that we get all of these different combinations. We get an empty list, right? Combination with 0 elements in it. And then the number 1, the number 2, 1 and 2, 3, 1 and 3, 2 and 3, 1, 2 and 3, so on and so forth. And this is exactly what we were expecting, right? This is what we had discussed when we were pre-conceptualizing the answer before we actually did it. So what's going on underneath the hood here? What is this actually doing that it got all of these numbers? Well, let's start. Let's clear out our output, and then let's look at what our iterable is. So every time we call this, what's our iterable? So the first time, it's that full length of numbers, right? 1, 2, 3, 4, 7. And then, exactly like we expected, we cut one number out every single time because we start at the first index instead of the 0th index. So instead of starting at 1, now we start at 2. And then we do another recursive call. We start at 3, and then we get 4, 7, and then we get 7, and then we get an empty list. But now, something to note about the language of Python is just, that's what happens. If you were to have a list with one number in it, so we have that last one, 7, in there. Let's clear this out. So we have a list with one number in it, and then we say print my list from the 0th index onward. We would get 7, obviously. But if we were to do index 1 onward, it would say, well, there's nothing after 7, so it's going to give us an empty list. And it would be the same if we started at the 10th index or the 100th index. That is just how the language works. So, okay, we know how we get to an empty list where we have no numbers list and how we hit our end case. So why is this important? Well, at what point are we hitting our recursive call? What we're doing is we're coming through here. We're saying do we have no numbers left? And when we start, we have 5 numbers. So we say, this isn't true, move on. So we instantiate our empty list, and then we hit our recursive call right here. So what we do is then, before we even go through this loop right here, we start over. And now we're saying, is our new iterable 0? No, our new iterable is 4, right? And then we do another recursive call with 3. And then we say, is 3 length of 0? No. And then we go through 2. 2 is not 0. 1 is not 0. Oh, look at that one. Empty list. That one has a length of 0. Okay, cool. So now that we have a length of 0, we return this list with an empty list in it. So we're going to say for combo in a list with an empty list in it, right? That's what we're saying at this point, because that's how the recursive call is working. So what we can do is we can look at this a little more visually. We can say print just to give us some space, and then we'll say print. Let's do this. Let's pull this out. We'll call this recursive loop, just so we can print this. So now we can see what we're actually looping through, because we're saying for combo in combinations of the iterable, right? So we're saying for combo in this recursive loop. So the first time we're looping through this list with one item in it, it's an empty list. And that makes sense, right? Because that's our base case. So if we don't start looping until we hit our base case, then it makes sense that this is the first thing we would loop through. So, okay, so we loop through one time, and then what is this doing? We're looking at the combo in here. So we're looking at the items in the recursive loop. So in this case, the first one is just going to be an empty list. And then we're also looking at an iterable. And what is the iterable? Well, it's this. Remember, we printed out the iterable. So the first time that we look at this, we're going to be looking at the number 7. And why are we looking at 7? Well, remember when we got to the empty list hit this statement, our base case right here. Let's just put a label on this, base case. So we hit this if statement right here, and then we returned. And when we return, we don't go through the rest of the function. So we have exited this part of the call stack, and we now go 1 up. So our iterable is now 7 when our recursive loop is this list with an empty list. So what we do is we say combos plus that empty list, right? Because that's that is the first item in the recursive loop, and then empty list plus 7, and that's exactly what we get: recursive list plus 7. But that's not the combo we're looking at. We're looking at the recursive loop right there. Interesting. So we're making a connection here. So let's do print combos then, and let's give this a label so that we know what we're looking at here. Loop, and then let's also look at combos. And okay, cool. So that's what we were expecting, right? We looped through an empty list, and we returned empty list and empty list plus 7. So that just turns into 7. So empty list and list with 7. Cool. That's exactly what we were expecting. And we were making that connection before, where our combos that we returned in the previous loop turned into the loop for the next one. Okay, interesting. But now that we have finished going through this iterable, we move on to the next iterable, 4 and 7. Okay, cool. So we're looping through here. We're going to have 2 items, empty list and 7. So we say the first one is going to be empty list, and we're going to have empty list plus the first iterable, which is 4, right? Because we're going through 4 and 7. So empty list and 4. And that is what we get. Now, this time, we're not going to have a new loop yet, because we haven't finished this iterable. We've only gone through the first item. Once we go through both items in the iterable, then we'll have a new loop. But for right now, because we haven't finished this one, we're going to have the same thing, empty list and 7, empty list and 7. This first one, our combo, right, combo, that was the empty list the first time. The second time, it's going to be 7. So now we're going to say 7 and 7 plus the first iterable, which is going to be 7 and 4, right? Because 4 is the first iterable item. So 4 and 7. And what we're doing here is we're appending onto combos. every single time that we go through this loop. So the first time we created empty list in 4, so we still have empty list in 4, and now we're putting onto this 7 and 7 and 4. So this is what we return out of this loop. We've finished this iterable, right? Our iterable was 4 and 7. We had 2 elements, and now we go on to 3, 4, and 7. Okay, so we've moved on to an iterable, so now this combos right here becomes our next loop. Cool. And also notice how we went from single items, right? The first time we went through, we had 0 and 7. And then the second time around, we ended up with 7 and 4. So we went from single item pairs to double item pairs. We got our first 2 item pair, 7 and 4. Okay, cool. So moving on now, we have our next loop. And remember, our iterable is 3, 4, and 7. So let's just write this up here to keep track of this a little better. 3, 4, and 7. So we have that. Where are we? Right here. Okay. So our first combo is still going to be that empty list. So empty list, and then the first iterable, which is 3. So empty list and 3, and that is what we get. Okay. And now we go to the next item in our loop, which is going to be 4. So we say 4 and 4 and 3, because 3 is the first item in our iterable. So 4 and 4 and 3. And that is what we get. So we got that original, right? The last loop, we got empty list and 3, empty list and 3. And now we're adding on to this 4 and 4 and 3. And we're going to have that in the next one too, because now we have 3 items, right? So 0, 3, sorry, not 0, empty list 3, 4, 4, 3, and 7, 3, because 7, and then 7 in the first iterable, which is 3, so 7, and then 7, 3. All right, but we have a fourth loop right here that we have to go through. This time we have 2 items in here. So this is going to be 7, 4, 7, 4. So 7, 4, and then 7, 4, and 3. Interesting, right? So now we have everything that we had up here. But along with this, we have 7, 4, and 7, 4, and 3. So you're starting to see how this recursive algorithm is building all of these different pairs and expanding to different lengths of pairs. We started with just single item pairs, and then we got double item pairs, right? 4 and 3, 7 and 3. And then we ended up with 7, 4, and 3. We got this 3 item pair, and this trend is going to continue. You can see if we just look at the results, let's see, 7, 4, and 3, we get 4, 3, and 2 here, so that's another 3 number pair. And it's going to take a bit before we get to that 4 item pair down here, which is going to be 7, 4, 3, 2. But this is the logic behind this, and you can follow it all the way through if you want to. It does loop through quite a bit of times when you have 5 numbers. But if you want to rewrite this algorithm yourself, play around with it a little more, maybe add some more print statements, and figure out what works for you to understand this algorithm, I encourage you to do so. If you have questions you think I could help you with, please leave them down in the comments. If you have learned anything about the thought process behind an algorithm like this, maybe you learned about recursion, because recursion is hard to learn and even harder to internalize and then come up with your own recursive algorithms. So if you have any questions about that, or if I helped you learn, shoot me a like, shoot me a subscribe, and I will see you guys in the next one.